The information presented here is intended to help maintenance managers and field personnel implement effective anti-icing programs. Further details can be found in the Federal Highway Administration publication, Manual of Practice for an Effective Anti-Icing Program. Anti-icing is a systematic approach to winter road maintenance that requires the use of the right tools, material, equipment, personnel, and strategy at the right place and at the right time to prevent or reduce the ice pavement bond. Many tools are available to the maintenance manager for anti-icing. Tools for operations include the solid, pre-wetted solid, and liquid chemicals necessary for preventing the ice pavement bond, equipment for delivering the chemicals at appropriate rates, plows with effective cutting edges, and chemical preparation and storage facilities. Personnel tools are the people skilled in the use of road weather information systems, snow and ice control equipment, technology for decision-making, and personnel standby and call-out procedures. Decision tools include long to short-term weather forecasts, real-time data on traffic, pavement condition, and treatment effectiveness. The purpose of an ice control chemical is to lower the freezing point of water, that is, to melt ice or prevent water from forming ice. Sodium chloride is the most commonly used chemical for anti-icing and de-icing. Its action in depressing the freezing point is typical of all common ice control chemicals. This is the phase diagram of salt-ice-water mixtures. Below the left part of the solid curve, there is not enough dissolved salt to melt ice. In fact, some of the solution freezes. Below the right part of the solid curve, some of the salt that is already dissolved precipitates out. Anywhere on the plot below the lowest temperature on the curve, called the eutectic, the solution with the lowest freezing point, no amount of applied salt will melt ice, and existing salt water will freeze. Timing of chemical applications is critical. Dry solid chemicals should not be applied on dry pavement because the particles can bounce off the pavement or be blown off by traffic. When applying dry solid chemicals, it is best to wait until early in the storm, when the pavement is wet or when frozen precipitation has begun to accumulate. The primary objective is to place the chemical early enough to prevent development of an ice pavement bond. There are circumstances when it is appropriate to apply a chemical on dry pavement. These include pre-treating as part of a pre-season preventive operation, beating rush hour traffic, and pre-treating for bridge deck or cold spot icing. In these circumstances, applying a pre-wetted salt or a liquid chemical will substantially reduce material loss, resulting in greater effectiveness. Tailgate spreaders and hopper spreaders can apply free-flowing granular materials in paths from 4 to 40 feet wide. Both types have been used successfully in anti-icing programs. Several methods can be used for pre-wetting. The most common is to spray the liquid on the dry chemical before it leaves the spinner. Sodium or calcium chloride solutions are most commonly used for pre-wetting. Ground speed-oriented spreader controllers are recommended as they automatically compensate for truck speed to maintain a constant material application rate with little demand on the driver. Anti-icing is most effectively accomplished using uniform chemical application at rates as low as 100 pounds per lane mile. Truck and spreader vibration, wear, damage, and maintenance can all affect application rate. This makes periodic recalibration essential. Calibration procedures are described in the Manual of Practice and in the Salt Institute's Snow Fighter Handbook. Ice control chemicals should be stored under cover or in a building to avoid loss into the environment. Stockpiles should be placed on an impermeable base to prevent groundwater contamination, and drainage from the truck loading area should be handled properly. Liquid chemicals are preferred for application on dry pavement. They also can be applied on wet or thin snow or thin ice-covered pavement. On snow, they must be applied before a pack develops. Until the thin ice is melted, a liquid will create a very slippery condition. Therefore, a liquid should not be applied to ice during critical traffic periods. 5 chemicals: calcium chloride, sodium chloride, magnesium chloride, calcium magnesium acetate, and potassium acetate have all been used in liquid anti-icing treatments. Calcium chloride has been used on some highways at rates down to 65 pounds per lane mile of equivalent solid chemical. 20 to 25% sodium chloride solutions have been shown to be effective for anti-icing and for removing frost and black ice. Magnesium chloride solutions have been effective in inhibiting development of black ice on bridge decks. Liquid chemicals applied during heavy snowfall or freezing rain can be diluted to the point that the solutions freeze unless very high quantities are used. It is best to use solid chemicals under those conditions. At pavement temperatures below about 23 degrees Fahrenheit, the anti-icing action of all chemicals is generally too slow to be practical. Even when mixed with calcium chloride, 15 degrees Fahrenheit may be the practical limit. Chemical solutions can be prepared by the user. For temporary or small-scale production of saturated brine, up to 600 gallons per hour, simple batch units can be built using small, commercially available sheet metal tanks. Because of its greater ability to penetrate ice or snowpack, salt used for de-icing is generally coarser than that used for anti-icing. Since anti-icing treatments are made before an ice or packed snow layer develops, penetration is not an objective. Finer salt will dissolve and coat the road surface with anti-icing solution faster, and its surface area holds more solution. Experience and studies suggest that the anti-icing chemical itself may not be as important as the application rate. To reduce chemical dilution, snow or loose ice should be plowed off the road before applying chemicals. This is good practice anytime chemicals are applied, but is even more important when liquid chemical solutions are used alone. Excess snow and ice will require more chemical to achieve an effective concentration. Plow cutting edges should ride on the pavement to remove as much snow and ice as possible. Casters or shoes should not be used unless required for safety on certain highway segments. A slush blade behind the cutting blade may be desirable. Choice of chemical and application rate, use of plowing alone, or doing nothing can all be informed decisions based on knowledge of the local conditions provided by road weather information systems. Pavement temperature sensors provide real-time data that can be used to predict several hours in advance when the pavement temperature will drop below freezing, allowing time to plan efficient operations. Conductivity sensors indicate the relative chemical concentration on the pavement surface. This helps guide the decision whether to apply more chemical. The newest pavement sensors can measure the freezing point of the chemical solution on the pavement and warn if the solution is likely to freeze. Timely, accurate weather forecasts are essential for making early and continuing operational decisions. One resource for forecasts is the National Weather Service. However, these forecasts are not generally specific enough for making anti-icing treatment decisions. Location-specific, timely forecasts can be obtained from contract forecast services. Guidance for selecting a forecast service is given in the report Sharp H351, Road Weather Information Systems, Volume 2, Implementation Guide. Information on all aspects of road weather information systems is given in Volume 1 of that report. The maintenance manager can use nowcasting to decide when to mobilize personnel and take other actions throughout the storm. Nowcasting uses real-time data from road weather information systems, road patrols, and any other sources to predict the weather and road conditions for the next 1 to 2 hours. For an anti-icing program to work, management, supervisory, and operations personnel must be trained in the program's details. New, more effective, and more efficient programs must be started. A successful program will require more and better information for making decisions, will use different methods and materials, and will require more emphasis on training. Training can be given by a consultant or by agency staff using material from various sources, including Sharp and FHWA studies. Appendix C of the Manual of Practice suggests maintenance actions for preventing the ice pavement bond during 6 distinctive winter weather events. It is intended to complement the decision-making and management practices of a systematic anti-icing program so that roads can be efficiently maintained in the best possible conditions. For example, for a moderate or heavy snowstorm with the pavement temperature between 25 and 30 degrees Fahrenheit, and the pavement surface is wet, slush, or covered with light snow at the time of the initial operation. A liquid should be applied at a rate of 200 or a solid chemical at a rate of 150 to 200 pounds of solids per lane mile. Subsequent operations would consist of plowing any accumulation off and reapplying liquid or solid chemical as needed at 200 pounds of solids per lane mile. If the desired plowing treatment frequency cannot be maintained, the application rate can be increased to 400 pounds per lane mile to accommodate longer operational cycles. Do not apply liquid chemicals onto thick snow accumulation or packed snow. Anti-icing is a systematic approach to winter road maintenance that requires the application of the right tools, material, equipment, strategy, and personnel at the right place and at the right time to minimize the impact of the ice pavement bond.